citrate and go.
Now after that you can change it. Right. You can write the units also. Next one is we will change this alpha values. So actually in the central composite design, this is the default values. Okay, now we will change. So just enter the factors. Okay, then we can edit here. Okay, just give one and one. This also.
What does it mean by negative alpha, positive alpha?
Actually, when you read the central composite design, the
I don't got pen. I didn't do a pencil.
Got pen and paper.
Yeah, you have a paper?
Remove in the chat. No, I cannot see from my.
composite, right? So if you go for box Benkan, see minimum is 3. That means there is more reliable data. But central composite is only 2 factors. So what it will think is it will extend the possibilities. So it won't not only think within the box, it will go beyond the box. So when it is going beyond the box, it will take square root. Okay, so the square root value is 1.414, right? So that's why it will take that value. It is beyond the box. So what we are doing is, anyway, we know the preliminary data already, so we don't want to go beyond that box. We are asking the software, you don't go beyond the level, you give within the, that means -1, 0, +1. But normally it will take -1.314, that means -1 plus 1.414, it will take -1.3 or -1.5, like it will take.
Okay.
Now we are asking, we don't want, we just do this.
Okay.
But if you click the box Benkan or other things, it's automatically take only 1. You see here, it haven't take any values. But when it is come to the central composite,
And then the units,
units,
that's
not
just
units.
the what? Millimole.
Our units mean what?
Units.
I think he's asking the second column.
Second column, right? So you are using gold. Gold you are using in percentage or mg or how you are using?
Percentage.
Percentage.
Oh, okay.
Yeah, our units.
Okay, one more. Now, so total how many central points we want? We don't want too many, so we'll put only. Central point means this value.
Yeah.
This value is asking because from this data we are assuring that our value will be closer to this region, right? Because you are not thinking that your value is here, your value is here. So that's why for the software, for the more confirmation, it will repeat the experiment so many times. That means whether you are getting the same value when I am doing the repeated times, you are getting the same value or not. So that's why it will ask you how many number of times you want. I am telling I want for 3 times. That means the same formula it will give 3 times. You see now. So when you reduce it, previously it is 13 runs are there, right? Previously it is 13 runs. Now it will make 11 runs. Or even if you give only one time, 9 times. So let it be 3 runs first. Because if you give only one run, so however you are calculating this formula, the same way here also you are doing only one formula. So suppose by chance if that formula gives some wrong results, but software will take that value only, right? So for that confirmation, it is asking more times. You give me, because how reliable that center point it is. Okay, so we'll give for 3 times.
It's good to have 3 times.
3 times. So now total it is giving 11 now. -1 or +1. Is not changing. No. How you are changing that? How you are changing that? -1 means what? Now, now you given one ratio, right, sir? I am getting the closest value with this concentration. What ratio?
1-to-1 ratio.
1 to
1
to 1. So that means this is here. This is what? Gold.
Yeah.
This is
Citrate.
citrate, right?
Yeah.
So what we'll take is gold. We'll take 0.8 minimum.
Okay.
1 ratio, 1.2 ratio.
Oh, okay.
In the same way, citrate 0.8, 1, 1.2. That means here the central value is which one?
1.
1 is to 1.
Mm.
This is the one. But now what software will do, you know? It will take 0.1 is to 0.8 first, 0.8 to 1 first, 0.8 to 1.2 first,
Oh, okay.
1 to, like that it will do different thing. And anyway, it will, we are giving 3 times, right? So it will repeat the same batch for 3 times.
Oh,
But
I see.
remaining is 1, 1, 1 time.
Okay.
Okay, in the same way. Suppose yours is 2 is to 1, for example. That means gold is 2, citrate is 1, right? So here what will take 1.5 to 2.5. That means how much, suppose if you are taking 0.5 difference means plus 1 also should be 0.5. Suppose if you take, no sir, 1.5 is very too, then you can take 1.8. Then 2, next one is
2.2.
2.2. That means you have given 0.2.
So how do you change that?
Yeah, how do you change the
The
whether it's
1.5
or
or-
That because you have done the preliminary studies, right?
Yeah.
You should know that one.
We
Because
change by 0.25 each, like 1 to 0.75.
then you give 0.25 difference.
Okay.
Okay.
I understand.
So that
Okay.
means you have to give the nearest one. Suppose 2 is to 1. Someone what they will give 1, 2, 3.
Ah.
But what is the point? Because you are. What is the point? Because you already know that one data is too different to
Yeah.
your targeted data. So no need one. So you want a little bit accurate data. So you can give the nearest value. So why I am telling is, suppose when you do, what is the conventional, what are the concentration you have taken?
1 to 1,
1 to 1,
1 to 0.75,
1 to 0.75,
1 to 0.5,
1 to 0.5.
yeah,
Hmm.
1 to 0.25,
1 to 0.25,
1 to 0.1.
1 to 0.1.
Yeah.
So that means you change only this concentration.
Yes.
You haven't changed
No.
this concentration. So this value comes nice, right?
Ah.
So now then you above 0.75 you play it, 0.8 you put it, because you already know the data until 0.75, so you play it 0.8.
Ah.
Yeah.
0.8 you play it. And that here the advantage is here you change only one concentration.
Yes.
But what I am thinking is instead of 1.1 maybe
You put
0.5 is to 1 will work out. That you haven't
yeah,
tried.
no.
yeah.
That you haven't tried.
Oh.
So that's why always it is better to play with two.
Okay.
Okay.
Two. So you have done this 1:1, right?
Yes.
Now
Yeah.
what you will do?
We
You just
haven't
change
changed goal.
you change this role also.
Okay.
Okay.
Maybe you need not to repeat all the experiment. You just change 1 or 2
Okay.
concentration, highest and lowest concentration you change. Then it will be easy for including the data.
Okay.
Because now you are telling, sir, the preliminary data what you get is based upon only one. Wait by one. Wait by one. The same. These are some x. Now minus value is 0.8. Plus value is 1.2.
1.2.
The same way here also. For example, this
Yeah,
I given
0.8.
0.5 I given. For example, this I given 1.5. Okay.
So it's still 1 to 1,
Ah.
correct? Yeah.
Ah.
Okay.
So, but it is taking, still both is 1
Ah,
1:1 on. But
correct.
see here is alpha value it is taking because it is taking -2, right? So see here how much alpha value given 1.414. So now this alpha value, where is the alpha value? I made it to only 1. Okay. Now you see -1 is 0.8, 1.2, 0.5, 1. That is whatever the values we given, it came here. But ideally it should be this one, 1.414. That means, as I told you, it is crossing the box. But anyway, now we don't want to cross within the box. That's why I given. Sorry, there is the one value. Say
It's
center.
center.
That means I am asking the system, you concentrate
Within the
only on the
box.
center.
Mm.
Okay, don't concentrate rotation or spherical or that things. Now, total is how many? 11 runs. Now you click the continue. So now, what is your target?
50
No.
nanometer.
What is that? Particle size.
50 nanometer.
No, I am not asking the value. Particle size is your independent variable, right?
Yeah.
Finally, you are looking for particle size. Correct?
Yeah.
So you write particle size.
Oh.
Because the target we will give after data comes. Particle size, nanometer, right?
Nanometer.
Yes, only one.
Yes.
We are not asking. Suppose if you have more targets, you can give more number. But at present we want only particle size, right? But here maximum you can go until 99 itself. But we are having only one. That means very simple design for you. Now see, how many formulas are given?
1.
See, total 11 formulas they given.
Okay.
1 is to 1.5, 1 is to 1, 1.2 is to 0.5, like that. It given so many things. Okay, 11 formulas. So you have to do these 11 formulas, and now you
They
have
will
to
just
fit.
fill in.
Yes. Suppose for example 1 I got 8. Okay. Next here I got no. Our target is how much?
50.
50.
Yeah.
Okay. Here I got 50. Here I got 67. Here I got 54. Here I got 32. Here I got 56. But you should not give different values. If you give different values, the software will get confused.
Mm.
So you have like that. So once you give this data, then we will ask to analyze the data. So this software will analyze all the data. It suggested one thing. Okay, so this is an ANOVA, everything it will show you. So these things you need to report. So see, fact not in a model. That means I given all different values, right? So that's why
So there's no model for it.
it's not able to understand why it is giving different values. Why? Because it has to follow one trend. For example, now 1 is to 1. When I did this one, particle size is 50. Okay, 1 is to 2. Particle size is 75. What is it meaning? When the
as the
concentration
ratio,
increasing,
yeah.
particle size is decreasing. Then when it is asked 0.5, that time if you give 80, is it making any sense?
No.
It is irreversible. So it is not following any trend. So that time software will get confused.
But if we have our own trend, because based on our results, we realize that as we decrease the ratio, the seed rate, the size go up.
Yes, at least one common sense should be there, right? If it is decreasing, particle size is increasing. That is one trend. So one time if it is decreasing, it is increasing. One time if it is increasing, decreasing.
Then it's confused.
So that time it will give different graphs. These graphs you need to remember. See here 3D surface graphs. So like this. So this is the graphs you are going to present in your thesis.
Okay.
Okay, like this graph. And next one is counter. This is the graph. And finally optimization. Really now it is the process now. So now particle size, our target. Okay, what is your goal? Our goal
Target.
is 50. 55 is taking, our target is 50, right? Yes, so I want 50. Now what is the response? It given different formulas. So what it is telling, if you take 1.2 and citrate 1, you will get the particle size of 59.
Why all is the same?
It is giving different, so we will take top 2 or top 3. Top 2. And
Any
here,
of these combinations you get the same.
but it is telling, see, desirability is 6.659. That indicates only 65% of the chances are there.
So if it's closer to 1, it's better.
Yes, that means whichever is the highest desirable value we have taken. Now why it is showing 65% means the data which we given is wrong.
Inconsistent.
Okay.
Inconsistent, not trend.
Okay.
So if the system understand your responses, then it will give highest 1.
Okay.
That means desirability is 1. That means 100%.
Okay.
So we will take top 2 or 3. We will do it. If you got a similar results, yes, the software is correct. Validation is finished. If it is not getting, so that means whatever the variables we have taken, it is not fitting to the software.
Okay.
So once we fit in all the values that we got from the Zeta Sizer into the software, Can you help us in
No, I will help. Everything I will help you. No, just I am telling the overall picture. I am not asking you to do everything.
Yeah.
Okay.
Okay.
Just you feed the values, then you come with the results. Then I will do all the processing to you.
Okay, sir.
Okay.
Okay?
Anything else, sir?
Anything else you want to ask me?
Not at the moment, sir.
For
We
now,
still
no.
got a lot of work to do. So this one can just transfer to anyone.
Yes. So just we will give this folder.
Okay.
So next, when is your
This
last
30th September.
30th September?
30th September presentation of all the findings. Dissertation is October.
So how far you are now?